All right, we're back. We're on page 107 of Notes 10 of Math Analysis. We are solving oblique triangles. We're using the law of sines, and right now we're talking about the ambiguous case. So I swear this is definitely true. There's a ton going on with the ambiguous case. It is better to understand it than it is to try to memorize all these different scenarios. Like, think about what's happening. You're standing there, you're swinging a thing back and forth. Is it going to connect the horizontal? Is it not going to connect? Is it too short? Is it too long? Like, what's going on? And if you think about that, you kind of end up with these pictures, right? So here, too short. Here, it's exactly the same as the height. You get one right triangle. Like, why would you not? Here is the weirdest one because you could connect twice. You might connect once at an acute angle or again at an obtuse angle. Like, you could get two triangles in that scenario. Then there's finally this one where it's just too long. It's going to connect once, but when it swings through, it's not going to connect again. So in that case, you get one triangle. So in all of these cases, if I'm dealing with an acute angle, I have the side opposite the angle and another given side. So I have angle side side, I have the ambiguous case. I draw the same picture every time. And the picture looks like this. Here to here to here. I call it the triangle. It is not a triangle. But because it's like when you're drawing a rectangle, you don't want to draw a square because a square has certain properties. You don't want to assume those properties. Here, I'm drawing the triangle because I don't know how many triangles there are. Maybe there are two triangles. Maybe there are no triangles. Maybe there's only one. So I just draw this sort of generic thing, and then I think of it in terms of the angle that I am given, which is here. I think of the side opposite that angle, which is this, and then I think of the other given side. So that's how I always refer to them. Angle, side opposite the angle, other given side. Angle, opposite, other. That's how I think about it. I always draw it this way. I don't care if it's accurate or not. Like, maybe this angle is 1 degree, whatever, I'm gonna draw this. Maybe it's 87 degrees, I'm gonna draw this. The only time I wouldn't draw this is if the angle is obtuse, in which case there's either a triangle or not a triangle, and it's pretty easy to think it through. So I will always draw that. And if the side opposite, so the first thing I want to think about is, I'm swinging a thing. Is it going to hit? Is it going to hit perfectly? Could it hit twice? Or is it longer than the other given side, in which case there's only one triangle, and you just immediately solve it. So your first thought is always, what's the relationship between the side opposite and the other given side? Because if the side opposite is bigger, there's one triangle, you solve it, and you're done. So it is like kind of hard to think of that, but you do need to. So here I have a side angle pair, which is good. Then I have another side. So this is definitely the ambiguous case. So you always look, do I have a side angle pair? Because that's law of sines. If I have a side angle pair and another angle, it's the normal law of sines, and you're just basically done. If you have a side angle pair and another side, that's going to be the ambiguous case. So this is the ambiguous case. So I'm going to draw the triangle. So I draw this, and then I usually just put the numbers. So 24, 22, and 14. Now what I want to do is I want to immediately, did I color code this somehow? I want to compare this with this. And since 22, so in this case, I know that the opposite is greater than the other. And if the opposite is greater than the other, there is one triangle, and we just solve it. So here we can immediately just pick up our calculator, well, set it up, pick up our calculator and solve it. So I'm gonna solve this. I'm gonna start off with the sine of A. So the thing I want angle A over 14 is gonna be the sine of 24 over 22. So I'm going to bring the 14 across and get that the sine of A is 14 sine of 24 over 22. And then I'm going to take the inverse sine and get that A is the sine inverse of 14 sine 24 over 22. Okay, so that's the exact value of that. Once I know A, I can do 180 minus whatever A is, minus 24 degrees, and that'll give me C. Once I know C, I can set up a ratio, and I can solve for side C. So that's the order in which I'm going to go, but I really do need to use a calculator on this. I guess. I mean, I know that ultimately I'm going to have, yeah, I should probably just use it. Let's just do the calculator thing. I was going to like write more stuff and, you know, work out some more stuff and blah, blah, blah. So remember, you have to be in degrees if you're working with degrees. So I'm already in degrees. If I wasn't, I would press doc 7, 2, arrow down, make it degrees, press enter. All right, so I'm set up. So I'm going to say that my angle A, so the calculator is not case sensitive. So like I could do capital A, and then I'm going to do arc sine of 14 sine 24 over 22. I'm going to put a decimal so that I get a decimal. So I get 50, oh, like 15.001. That's close. 15.001 degrees, 3 decimal places all the time. So now what I need to do is, I guess I'll like go, well, I'm going to do 180 minus A minus 24 gives me 140.999. Okay, so 140.999 degrees. And then I need to solve for C. So I know that like I'm going to do C over the sine of C. So let me store this as C. Okay, so I'm going to do side C over the sine. Oh, can't call it C now because I just stored that. I'll just put X right now over the sine of C. And that should be equal to, what do we know? 22 over the sine of 24. I'm going to go back and handwrite this at some point. So I can do this. And then I can do like the really cheap thing and just solve for X. I could have actually done that to begin with. So 34.0, ooh, 34.040, the worst kind of rounding. So let's just try to confirm this. So we're saying that 14 over the sine of A, because we stored that, is this. 22 over the sine of 24. Okay, and then I didn't store that value, so can I just, what should I do? I'm gonna paste this down. Ugh. And then delete this over the sine of C, which I did store, and get this. So I got that. So they're all good. So let's just go back and handwrite the work, because you gotta have the work on paper. Like just because you're able to do it on a calculator, I think I could do almost the entire course on a calculator if I needed to. I don't know why I would ever need to do that. But it's the work that matters, right? So like I've already handwritten in all of my answers, but now I need to set this up. So I'm actually just gonna write C over the sine of C equals 22 over the sine of 24. Like this is enough work, and then you just grab a calculator. So C is gonna be 22 sine of C over the sine of 24, and you get that. So this is like the textbook example. I guess, I mean, if the notes are the textbook, this is literally the textbook example. Let me highlight some things so you can see where they came from. I guess that's literally the only thing I really need to show. So we knew there was one triangle because opposite was greater than other, so there's no point in calculating the height in this case. We don't need it. And then once we did that, we were able to just use the law of sines. Like it's a straight up law of sines problem once you've established this. So this is the situation. We had, you're given the ambiguous case, right? An angle side pair and another side. If you have an angle side pair and another angle, not ambiguous, just use the law of sines. So you have an acute angle, the side opposite that angle, and another given side. The side opposite the angle is bigger than, or it could be equal, in which case you get an isosceles triangle, is bigger than, I prefer bigger, opposite is greater than or equal to the other side. You always get one triangle, use the law of sines, and you're done. So I'm gonna stop this video here, come back in the next one, and probably take a look at another case. So I will see you there.